Hello guys, welcome back to another video. In today's video, we're going to actually be teaching you guys how to do wall running. So I just made wall running into my game and immediately I was like, okay, now it's time to actually share with everybody else. And this is going to be around the same system that I use. Mine is obviously modified for my game, but this is going to be pretty customizable for yours. And I hope you guys can learn a lot from this because I will be dissecting everything that was into the thought process of this system. And you guys don't like a lot of it is pretty complex, so I don't expect you guys to understand every single part. But if you do learn something from this, please like and subscribe. It helps a lot. I just want to say thank you guys for also a lot of support recently. I'm at 60 subscribers now, and with all the time I've been taking off and not making videos because of final exams and whatnot, I really appreciate the support I've been getting in my Discord server as well. So if you guys want to see more videos like this, please hop in the Discord server and yeah, subscribe for more. So let's actually get right into it. So for the first thing in the system that we're gonna need is we're gonna need our wall run left and our wall run right animations. I have the animation spoofer plugin. You guys should probably get this too. It's pretty useful. I just find any animation from the toolbox for the sake of this video, and I just spoof it using this spoofer plugin, which is pretty nice. It's really useful, and you guys should definitely give it a shot. But get your left and right wall run animations, and that should really be about it. If you guys want to play sounds as well, that should work too. But let's hop into starter player. And then let's hop into starter character scripts. Yes, we're going to do that. And let's make a new script. I'm going to name this movement, or I'm going to just call this wall run for now. But this is pretty customizable for your wall run movement system. Now, I'm going to actually make a part right here. And this is going to be the wall we're going to run on. So I am just going to... I hate this new update. It sucks. We're just going to scale this pretty high. And let's make this new part. It's not long enough. Yeah, let's make it like that long. I'm gonna anchor this as well. I'll name it run part, something like that. And let's bring it close to the spawn area so we don't have to like walk and all that bullshit. So let's move this up. There we go. And I'm gonna keep it levitating above the ground a little bit. Now, the one thing, if you do want your parts to be runnable, like you can run on them, let's give them all a tag, and I'm gonna call this wall run. You can call this runnable, whatever you want, but mine's going to be called wall run for simplicity's sake. Next thing we're going to do is we're going to hop into the script, and anything in starter's character scripts will be parented to the player's character, which is pretty nice. So I can actually say char, local character, is our script.parent, because this is in starter character scripts. Then I'm going to say local humanoid. I'm going to type check this so we can actually access all the stuff. And I'm going to wait for child humanoid, local animator, which is going to be an animator instance. Is this going to be humanoid wait for child animator. I'm also going to give reference to the replicated storage. So let's do that. And let's actually give reference to our anims folder. Is equal to rs wait for child animations. Perfect. Now we need some run service as well, because we're gonna actually play this on every heartbeat of the server, and we're gonna use run service.heartbeat instead of a loop, like a while loop, because it's just more performance friendly, if in that sense. While loops are too fast for this, and a run service will run on the given frames for a server that you aren't. So it can max out at like 60 FPS or 60 times it'll run in a second, which is gonna help us with lag and whatnot. You could also make the system temporary connection as well with run service if you want to, if you only want it to be contextually activated for the wall runs. But I'm not going to do that. This is going to be a really simple guide. I hope you guys can build off of this in your system and just use this as a blueprint for now. The next thing we're going to do actually is we're going to load our animations. So I'm just going to say local wall run L is just equal to anims folder and wait for child's wall run L. And actually I'm going to wrap this in the animator load animation function right here. And then yes, our animation to actually load is wall run left. Perfect. And we're going to do the same thing with our right wall run as well. So let's just hop into here and just do as so. There we go. Now our animations are loaded. And then now what we can do is simply start writing our wall run logic. So we're going to say run service.heartbeat, connect the function, and it takes in delta time. We're not going to use that, but I just like to actually put it. So let's make our configs as well. Let's say local wall run distance. So this is going to be the distance it takes to actually activate the wall run. I'm going to say 3 studs. So I have to be 3 studs in the direction of the wall to actually activate my wall run. You can customize this however you like. I'm going to say wall run speed is equal to 15. So this will be 15 studs in a second. I'm going to say 15 studs a second. That's my speed. And 3 studs in distance to activate. Right here, just some comments for whenever you want to come back to this. And we're going to say local is while running. We're going to have a check inside the actual client script to check for this is false. So automatically we are not while running. Next things next. I actually do like doing this a lot. I'm going to say, oh wait, actually let's get the player. Let's get the player. Is equal to game. Yeah, player is that local player. There we go. I'm going to say player.character added. I'm going to do this. And actually, let me just say this. Sorry. Actually, no. The script that parent is fine, yeah. Character added, connect the function of new char. Boom. I'm going to say character is equal to new char. And what this is going to do is I don't have to keep re-referencing character in every single like new function that I make. I hope you guys can actually use this in your movement system because you would find that you would have to redefinize character. So like character, something like that is equal to player.character right now at that time of the script. But because the reason why is if you die, the character will actually this instance that it points to, or sorry, not points to, this variable holds memory of when you before you died of that character, and you have a new character. We're not gonna have the right character instance to actually use. So I'm just gonna say every time the character is added, it means every time you respawn, this character instance will be this new character model because this is a new model that is taken into this function. And what this is going to do is we're not going to have to keep resetting this character variable. We can just keep using this forever in the script, which is really useful. It saves a lot of writing. So now what we're going to say is we need to shoot 2 raycasts now. We need to shoot a raycast from the right vector and the left vector of our character's humanoid root part. What this is going to do is that it's going to shoot a raycast and see if that cast actually touches something. So if we jump onto the side, if we shoot a right cast, we're going to check 3 studs that we defined right here. We're going to check 3 studs to the right or left if there's actually something touching that cast. If you guys don't know what raycasting is, basically to keep it simple, we have an origin point, our root part obviously, and we're going to shoot a certain amount of studs in a direction that we want. And through that point that we're shooting from, it creates some sort of part or ray really, and if that ray touches something, we're going to get something returned back to us in the script, which is going to be useful. So we're going to know if that ray we're going to create for every character, if it touches like an actual part, like this part right here, it's going to tell us in the script every heartbeat, which is why we use some sort of loop to check every second, hey, are we touching something? So that's a pretty brief rundown of raycasting. So let's actually make some casts. So we need to make 2 casts. So I'm going to just say wall run logic, just for some cool organization. I'm going to say local left wall, which is going to be a cast that I'm going to call. And I'm going to say workspace colon raycast. Now we have our raycast method. Our origin is just going to be the root part. Let me actually define the root part right here. So let me just say right after humanoid local root is just equal to character wait for child humanoid root part. Every character will have some sort of, I'm going to actually type check this as well. So I'm going to say base part. There we go. Just so I can see all the vectors and C-frames and all those stuff. But yeah, every character will have their own root part, which is just the root center of everybody's character, which is what we're going to use for every single like thing that we use for detecting like a player's position and whatnot. But we're going to use that in this case to actually detect the origin of our cast. Our cast is going to start in the middle of our player. So, or like a little bit below the torso. So now we're going to say the origin is just going to be a vector 3 value. So we're going to say root. Oh shit, it's laggy. Root.position. Now we're also going to say direction is going to be root dot position dot root dot c frame dot right vector. So we need a vector which is going to be our right vector. A right vector is just going to be the right value of your part that we're looking from. So if I have this part, the right value of it is wherever it's facing in the right value. So if we have a look vector, which is another thing that we have, it's going to be where you're looking at, like the forward direction. But the right direction is just the right of our humanoid root part, or sorry, our position of our part right here. So it's just going to check to the right of your character, basically. And then we need to actually make some raycast params. So I'm going to say local params, raycast params.new, and then we're going to say params.filter type is just enum.raycast filter type.exclude. This is going to exclude everything that we put into this table right now. And we're going to say character. So we don't, if the raycast touches the character, it'll actually return something to us, and it's going to count that as a wall. We don't want that, so we're going to exclude that from our actual array. So now what we're going to do is we're going to say right vector, and we're going to multiply it by our distance. The reason why we do this is because when we multiply a vector by some sort of constant number, it's going to shoot that vector in that distance direction. So it's going to become 3 studs now. Now this, instead of the vector being right at the direction of the humanoid root part, it's going to shoot it 3 studs from here. And that's basically just how we should make the vector bigger. If I wanted to make this, I made it speed by accident. Well, distance, sorry. So if we multiply that by our distance, if I make this like 10, it'll shoot 10 studs to the right. Now I'm going to put in our params, and we should be fine. I think, yeah, the general syntax is actually like this. So I'm just going to put it like this. Hold on. Let me just put it like this. Boom. And then boom. There we go. Now we should have some sort of left raycast. Now, perfect. The next thing we can do, guys, is we can make our right wall. So we're going to check for the right white wall, and we're going to raycast, and we're going to do the same logic. But you might be asking, root dot position, and then we're going to say, sorry, let me do this. And then now we're going to say negative root dot cframe dot right vector times the distance. The reason why we make it negative is because we don't actually have a left vector. Did I forget something? Negative root dot c. Oh, wait, no, what? It's the negative value of the root times distance params. Let me just format. Oh, was it not formatted right? What the hell? Oh, wow. That's weird. If I format it. What the hell? Okay. Anyways, I've never seen that. But yeah, we don't actually have like a left vector value, so we just make it negative right, because obviously the negative value of the right would be the left value. Perfect. Now what we're going to say is if, so now we're going to actually say local wall hit is equal to right wall or left wall. And now we're going to say wall side is equal to if right wall, then we're going to say right wall. Else, if it's the left side, then we're going to say left wall. This is for the animations. And then perfect. So now we're going to say if wall hit and wall hit has tag. So if we have that tag that we made earlier, what I name it? I think I named it wall run. Let me just check real quick. Wall run, perfect. Now if wall and has the tag wall run, then we're just going to say, and now when this is, we're going to be start wall running, and then I'm going to pass in the wall that's hit and the wall side, and then else we're going to else stop wall run. Okay, perfect. So we actually have these as stubs, so let's make some functions now. So now let's say local function start wall run of our wall hit and our wall hit and our wall side. Perfect. And then now I'm just going to make a stub right here, or not a stub, sorry. Local wall run BV, and this is going to be nil. This is going to be nothing. This is going to be, we're going to set this later. Now we're going to start our wall run, and our logic is going to be as so. If, no. We're going to say is wall running is equal to true. Perfect. Then we're going to say if not wall run BV, which is nil, then wall run BV is going to be a new body velocity instance. And body velocity is just it's a velocity on your body. It just pushes us forward. And this is going to be simulating wall running. We're going to say what dot, excuse me. I'm going to say dot parent is equal to the root part. So we're going to push along there. I'm going to say wall run that velocity is equal to vector3 dot new 111 times math dot huge. Or we didn't have to do that. We could do like 30,000 or something. And then, oh, no, sorry. Max velocity. Oh, shit. Something like that. I think it's max velocity. When we get the error, we'll fix it. That's not good practice. Don't be like me. And then the actual velocity of this is going to be something a little complicated. So let's actually start that. So now we need to, before we actually define any of this, I'm just going to get rid of this. Hold on. There we go. Now we need to actually get the direction of our wall running. So we need to run along, let me just, oh shit. So we need to actually run alongside the wall and not into the wall. And we need to do some little bit of math to do so. Because we want to run alongside like this. Or if on the left side, we need to run along like this, not into the wall like so, like how I'm doing. So we need to see where does the wall push outwards in what direction, and where does it face as well. So we're going to actually do that right now. So we're going to say forward value, which is going to be our forward value, which is going to be our look vector. And then next we're going to take in our normal value, which is going to be the wall's direction. So you might be wondering, what the hell is even any of this? Let's actually fill in some parameters right now. So then we're just going to say local run direction. I'm going to make it a variable because we're going to return something right here. It's just equal to get wall run direction of our forward value, our root.cframe.look vector, because we're looking forward. When we run alongside, we're going to look forward, right? And then the next thing we're going to do is we need to look along the wall. So the wall that we got hit. And now the next thing we need to do is we need to make the actual direction is equal to forward minus forward value against dot of our normal times normal, so squared. So you might be wondering, what even is this? And we got to return the unit. Because we're in a direction, we need to get the unit value. Direct unit is just a measurement of direction. It's where we're facing. And we don't care how big this unit is. We just need to know, where am I facing? And this unit is going to make us face along this way. If I'm running this way. If I'm running on this axis, I'm going to run this way. So you might be wondering, what does any of this even mean? This is Calc 3, linear algebra stuff, college math, and whatnot. I don't expect you guys to know what any of this means. Basically, we're just figuring out how do we run alongside the wall and not into the wall. That's why we subtract and whatnot. The dot product is just how two vectors, our forward vector, which is our look vector that we had right here, and our normal vector, which we're going to fill in 1 second. How do those two vectors, where do they point closest to at what? It's going to return either 1, 0, or -1. If it's 1, they're both facing the same direction. If it's 0, they're perpendicular 90 degrees. And if it's -1, they are not facing the same direction. I believe so. Or no, they're facing the opposite direction, yes. That's a lot to take in. I don't expect you guys to know any of it, but the more you know. Now we need to actually get the normal value, which is something that the right wall and the left wall gives us because it's a raycast. A raycast will always give us some sort of normal value. So we need to do that right now. So our local normal, right, is just going to be equal to, and actually let's make our forward value up here. It's for simplicity's sake. Root.cframe.look vector. And our normal value is just going to be our wall hit dot normal. Awesome. Now what we're going to do is we're just going to simply say forward and normal. Awesome. Now we have our run direction, and now we have our direction. So now down here, I can actually say a wall run body velocity, or this velocity, is going to be a vector. And we're going to make this vector along this axis. Or sorry, what? Along these numbers, upon these XYZ axis. So upon the X axis we're going to be running, we need to apply the velocity to boost you forward along X, Y, and Z. Forward, backwards, left, right, up and down. Up and down. Yeah, up and down for the Y value. So we're just going to say run direction dot X value because we're returning some sort of direction unit. Then we're going to say some arbitrary number. I'm going to say 2. And then run direction dot Y value. Or sorry, dot Z. You might be wondering, and I can actually, let's do this, multiply these by the speed, because this is our speed. Times wall run speed. There we go. Perfect. Now these values will be multiplied alongside that speed value. Now this 2 value, if you want the player to slowly go up as they're wall running, then you set it to 2. If you want them to slowly go down, we can set it to negative. So I'm going to set it down to like negative, and I'm going to say like -4 or something like that. Just so you guys can see. Okay, awesome. Now we have the calculations for our wall run direction, and we're actually applying the velocity. Let's just put it down here. So now I'm just going to say, I'm going to just literally call this one more time. Perfect. And I'm going to get rid of this. Okay, there we go. And then our forward is just going to be, oh, did I forget to copy the forward? Oh, I must have, huh? Okay. No biggie. There we go. Cool. Now, we're not done here. Now, we have it set for 1 time, but you may be wondering, well, if we're running this over and over, we might have to account for that, right? Which we're going to do. So we're just going to say if is while running, then return. And beforehand, we're going to say, because if we are while running, then there is a body velocity instance. So we're just going to say while run bv dot velocity. And let me do this. This is really annoying. Oh, my mouse is so bad. Let me actually call this body velocity. And I'm going to put a question mark so that the script actually doesn't know for sure. There we go. Thank God. Oh my goodness, that was so annoying. It's just equal to this right here. And we're gonna just copy and paste this. So perfect. And I always forget to put the freaking normal. But yeah, now we're gonna keep slowly updating our direction and where we're running across if we're wall running. You see that? Pretty freaking neat, huh? Whew, holy shit. That was a lot to take in. Now that sounded like a lot, but it's really only like 50 lines of code so far. Wow. Okay. Now the next logic. We need to actually stop the wall run. So local function stop wall run. So I forgot to put animations. We'll do that in a second. So now we're gonna say if not is wall running, then return end. If we're not wall running, we don't have to keep calling this over and over. We're gonna say if body velocity, wall run body velocity, then we're going to destroy it, set it to nil, and we're going to down here we're going to play atoms. So we're gonna stop atoms as well. And theoretically, everything that we wrote should be working. I'm going to test this right now. Maybe there's a bug I forgot to do. So I'm going to open the output, and we're going to see what exactly happened, any errors, anything like that. But theoretically, everything we did write down should be correct. And we're going to see right now if my thing is not slow. So I'm just going to shift lock. And I wish I was a little bit faster. I had like a jumping. Okay. Hashtag is not a valid member of raycast result. Ah, I see. I forgot to say wall hit that instance. Okay. Because it hits something. The instance is what it hits. Okay. That instance. Yeah. Okay. And I should probably say if there's actually an instance instead of just the wall hit. Because there's always going to be a cast, but not an instance, if that makes sense. Okay, now I should index nil with instance. Okay, I should probably say if wall hit and wall hit. Blah, 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 blah. Right wall or left wall. Raycasting. Blah, blah, blah. Maybe I should do that. And let me see actually what's happening here. Did I see frame? Yeah. Okay, cool. So now let me just see if there's any errors. Okay, max velocity is not a member. Okay, perfect. So now there is a bunch of errors I did make. I just kind of freestyled this whole video, I'm not gonna lie. But max velocity, okay, max, I think it's max force. Let me actually just make a BV is equal to instance new body velocity. This happens a lot, guys. This is gonna happen a lot when you script. Max force, okay, yeah. So max force and should be good. That should be good. I'm gonna get rid of that. Parent is root, instance new. Yeah, it should be good. It should be good. Okay. Okay. And index nil velocity once again. Holy. Okay. If not one below the body velocity, we're just gonna make it into. Oh, no. I should probably say if there is a body velocity. If there already is a body velocity. So I'm gonna say if body velocity. Wall run BV. Yeah, if there already is a wall run BV, then we can do that. Lots of errors. I kind of just freestyled this video. And okay. Pretty cool. There we go. Yeah. But as you guys can see, the distance is a little too far and whatnot. But if we like this, boom, boom, boom. So you might be saying, well, what even is this like? But we need to play the animations as well. So we're gonna do that. And usually wall running is gonna be a little bit higher. You don't wall run from here, which is we're not gonna have anything interfering. So let's do that. I'm gonna make this a little bit higher. I'm going to come right here into starter player. I'm going to say walk speed is like 24. And I'm going to say jump power, or this height is like 10.2. So we have some hops. And now we're going to actually play this wall running animation. So now what I'm going to say is that down here, if we're actually wall running, and I'm going to say wall run right play. Or no, sorry. If wall side is equal to, let's see, what did I say down here? Right wall, then wall run right play, and then else wall run left play. And you can even do this: wall run left stop, and then if the wall run left left is playing, we can say wall run right stop, and we're gonna stop, yeah. And then down here, we need to stop the animations as well. Doesn't matter which one. I had some issues, so I'm just gonna literally stop both. That's what I'm gonna do. I'm gonna stop both of the animations. Not optimal, but it is pretty easily customizable and saved me a bunch of headache. Just why not? Theoretically, we should be chilling. Okay, let's see it now. And let me see my hops. I don't think I have enough hops. Oh no, I don't have enough hops. Okay, hold on. Load animation. Okay. Yeah, I'm gonna just put this down here. And then now we should see. Okay. Very interesting. So the wall running theoretically does work, but something is up here. My wall run, I probably made some stupid mistake. My wall run animations are not playing. Load animation. I'm loading to the animator. Okay. Oh, I'm in R15. That's why. I'm so silly. I'm loading it. My animations are R6. Okay, hold on. Don't be like me. Let me change my avatar for the actual play. How do I even do that? Yeah, right here. So if you guys don't know how to change your thingy, okay. Make sure your animations are for the actual rig for your actually your game. Let me say R6 only. Save changes. I have in saving will restart. Bruh. Okay, I have to cut this out of the freaking episode. Oh, I don't have to restart? Okay. Okay, now we should be able to do that. Okay, that's a lot of fluff. That's annoying. There we go. Now I'm R6. Okay, now I should be able to. Okay, there we go. And there seems to be an issue. Interesting. Okay, I have it. I have it to the opposite. How did I do that? Okay, let me see. But yeah, let me actually see what I did wrong here. Let me change up some of these values too. Let me say the speed is like 25 and the distance is like 3. And we're gonna come down here. If the wall side is equal to right wall, then am I pressing the right wall? Oh my god, I'm so stupid. Oh my god. How did nobody catch? Oh my, I made a mistake here. This is the opposite. The left vector, I hope you guys caught this before I did. The left wall is the negative direction of the right vector. The right wall is the right vector. I don't know how I mixed those two up. My brain is not on today. Sorry. We all make mistakes. It happens. It'll be the dumbest shit to catch you. There we go. Now. There we go. And I as you can see, pretty cool, huh? And it's not. So the calculations that we did make were supposed to be like, it's supposed to like give you like a spacing from the wall, so you're not into it. You're just like gliding across from it. You can make the distance like a little bit less to give it that feel like, oh, but yeah, look, see that? It's nice. And look, if there's no raycast, we simply fall off. If there's nothing to my left and I look this way, body velocity gets destroyed, which is pretty neat. Pretty freaking neat. And you can customize this however you like. I like to make mine actually make you go upwards, and when you fall off, you jump. But that's a pretty easy blueprint for this system right here. Pretty easy. Nothing crazy. Only 100 lines of code. I'm going to format this. I'll leave this in the comments for you guys to take if you guys would like to use it. I hope this video helped you guys a lot. I hope you guys learned as much as I did for this video. Pretty simple system. Pretty cool. Pretty nice. I'm going to make this not a negative value. I'm going to do this. There we go. And we're going to see exactly how this looks like if I make it a positive value. And there we go. Look, I'm running upwards instead of downwards, which is pretty nice. You can add some VFX if you'd like. I'm not going to go into that. If you guys would like to see more from this series, like a more advanced tutorial, something really cool, like you can jump off and it'll like wall jumps basically. You guys just have to let me know in in the comments, like and subscribe, all of that good stuff. And yeah, I hope this tutorial helped you guys a lot. I know for me it was a really fun experience. This had me stuck for a little bit, and then I realized it was really simple. Hope you guys enjoyed. I'll see you guys in the next one. Peace.